All right. What do we got to do with this one here? This x squared minus 1. What happens with that? Okay, does that give us any zeros? It does. Okay, where does that equal to? Now, there's a couple things you can do. You can set that equal to 0. Now, you know that this is going to give us a 0 at x equals 0. And this is going to give us 1 at x equals 1. But what's going to happen here? There's two ways you can do that. You can either set it equal to 0 and go that way, or it factors. What does x squared minus 1 factor into? X plus 1 and x minus 1. So f of x equals, you got negative x squared. That can factor into x minus 1 times x plus 1, plus we got this x plus 1 here. So actually, how many x plus 1s do I have? I got 2 of them. So this can become negative x squared, x minus 1 times x plus 1 quantity squared. Now it's going to be really tight around that x-axis because you got things at negative 1, 0, and 1. So it's going to be hard to see on your calculator. I just need to see just the basic shape. So it's going to hit at negative 1, which I'm going to move 1, 2, 3, all the way over here just so I can spread things out. And it's going to hit here at 1. And so what's my overall degree? I got a squared, I got another squared, so I got 2, 3, 4. I got fifth degree, negative leading coefficient. So it has to open from positive to negative. At x equals negative 1, it's got to bounce. At x equals 1, it goes straight through, and at x equals 0, it's going to bounce. So at negative 1, okay, and it's just got to bounce a little bit. Just go there. And what happens at 0? It also does what? Bounces. And then what happens at 1? Goes through. So that creates our end behavior. Okay, so if I start up here and I go bounce, bounce straight through, it's going to go down to negative infinity. So you just got to show it going up above there. And I know it doesn't go very much above there if you looked at the graph. Okay, it's very hard to see. But let's just show that. So that would be 70. That would be 71. So you got to take into account. Now, 73. You got x squared. You got x squared plus 1. You got x minus 2. This is x equals 0. It will bounce. This is x equals 2. Multiplicity 1, it'll go straight through. But we got to watch out here. You got x squared plus 1. That doesn't factor. Okay, that doesn't factor at all because at x minus 1 times x plus 1 doesn't work. Okay. And so now, but what does that do? Let me see something. Go ahead and graph it if you have it. I'm going to pull up my calculator. I'm not sure what issues we're going to run into, but I want to see it. All right, so we got x squared, parentheses, x squared plus 1, x minus 2. And I'm going to zoom 6. Let's just see what's happening here. All right, we can see well enough. Okay. What are the only two places it hits the x-axis? It hits it at 0, and it hits it at 2. Okay, that's it. Okay, and that's correct. This overall degree, 2, 3, 4, this is a fifth degree function. Positive leading coefficient. So it has to look like this. Hold on, I didn't draw that very good. Okay, it hits at 0. I'm going to make this 1. I'm going to make this 2. Spread it out a little bit. Okay, and it goes up through there. All right, so there's that graph. Why doesn't this account for anything on the x-axis? Well, if you think about it, you set that equal to 0. You get x squared equals -1. Okay? X squared equals -1. If you take the square root, what's the square root of -1? It's I. It's actually plus or minus I. So you take your square root, you get x equals plus or minus I. This is the real number system. There's no i's on here. So it doesn't show up. Okay, it's not going to give you a root at 0 because these are all real numbers. This is an imaginary number. So if you end up with something in your equation like this, it will not add an extra 0 into the answer. Okay, so you just take these two. Okay, it bounces here and it goes through 2 there. Those will be your only 2 x-intercepts. Okay, so just want to make sure I hit these two kind of together. First one here, 71. That does factor. So that will change, since you already have an x plus 1, that will change that multiplicity. So if you thought it had a multiplicity of 1 and then all of a sudden it had a multiplicity of 2, that's why. And if you got a plus, x squared plus 1 or x squared plus 4, that's not going to affect your zeros. Okay, you do not add an extra 0. Okay. All right, also on that same section, let's do number 85 on page 349. We're going to do that together. Read through that. Star this one, highlight it. You're going to need to know this. All right, you got a rectangular sheet of paper. Okay, 8 by 15. We have a piece of cardboard. We're going to cut out 4 congruent squares with side length, and then we're going to fold that to make a box without a lid on it. Okay. And it says we want to find find the volume of the box as a function of x. So we got to come up with a function based upon this. Well, what is the volume? How do you find the volume of anything? Nathan, do you remember? So that's what we're going to start with. Volume equals length times width times height. How do I represent length? Volume equals length times width times height. Now, you're taking out, that's going to be a length of x on all these little corners. Now, the original piece of paper or cardboard is what, 8 by 15? So this whole length is 8. And then the length up above here, that is 15. How can I represent the length, the width, and the height for after it's folded up? Okay. All right. Anybody any ideas what the height will be? Luke, you want to take a stab at it?
8 minus 2x.
That's not the height, but that does come into play. Then what would that be? That would be this distance right here. That would be here to here. That is 8 minus 2x. That would be, I would consider that the width. Okay? So when you're folding that up, that would be our width. So if we stay on there, what's the length going to be? The whole thing's 15. We take out 2x's. It's going to be what? 15 minus 2x. So that's going to be this. What's going to be the height, though? This would be the height. Alex? X. X is going to be the height. So let's put this all together. So volume, we said the length is 15 minus 2x. We said the width is 8 minus 2x, and we said the height is x. All right, I want you to sketch that graph without using your calculator yet. What is the basic shape of that graph going to be? Knowing what we know. Okay, so this is, we did all this yesterday so that we can apply it to this. What degree is it? And what's his leading coefficient? All right, so as you think through that one. Austin, do you know what degree it is?
Third degree.
Third degree, do you know how to figure out the leading coefficient?
Just leave x.
The leading coefficient or the leading term would have to be the x to the third power.
Oh yeah.
Like after you multiplied everything out.
Mm.
Okay. Any ideas how we would find that based upon what you see here? I don't want to multiply it all out. Like I don't want to do that. Okay. So take a look. Before, when you had things written like x minus 3 times x plus 4, you just multiplied the x's. Same thing here though. My x is in a different spot. Doesn't matter. Okay. Negative 2x times x. Multiply those three together. What's it give us? 4x cubed. That's your leading term. Okay, so your leading term is 4x cubed. So that means it has to go from low to high. It has to go from negative spots. So it has to look like that. All right, what are my zeros going to be? Let's see, what was it? So 85. So we found A. All right, now we're sketching the graph of that. So we're doing B. So this would be A right here. B says sketch the graph. All right, I got the leading term. I know what degree it is. What are the zeros? We'll solve each of those for 0. All right, well, this one out here in the end, that's going to give me x equals 0. And what about 15 minus 2x equals 0? And what about 8 minus 2x equals 0? Okay, solve those. All right, Colton, let me know what you get.
I got x equals 0, x equals 7.5, and x equals -4.
Okay. You said -4?
Or no, it would be +4.
+4. Okay, so I'm going to graph this. It hits 0, it hits at 4, and it hits at 7.5. And we're going to sketch the graph in its third degree. Are all those multiplicity 1, or does anything have a higher multiplicity? They're all multiplicity 1. So it just goes straight through. It goes straight through. So it's going to look like this. And that matches our end behavior. So that's third degree. Is there a part C on there?
No.
All right, now what I want you to do is look at 86. What's the largest possible volume of the box? Use your graphing calculator. Well, looking at this graph, can anybody tell me where that largest possible volume is located at? Where that is? Okay, for this situation. Okay, so where are we looking for? Can't be anything here. Now you got to think, we got some constraints we're dealing with. We're cutting out, so we can't cut out a negative amount. Can you cut out an amount bigger than 15? No, what's the biggest amount you can cut out? Think about it. What's the biggest amount we can cut out? Austin, what do you think?
Um,
I'm cutting it out of all 4 sides. Josh, any ideas?
no.
No. Maggie? All right. Think. Todd?
Is it X?
No. I need a number. Brian? Kate?
Is it 8 by 15?
8 by 15 is the length. So we're cutting a piece of that out. Okay? Can I cut an inch out of each side? Brooklyn? Yeah. Can I cut 2 inches out of each side? Okay. So I'm going to get to a maximum amount I can cut out of each side. So we got to examine that. What's going to be that maximum amount? This side is how long? 8. Can I cut 5 inches off of here and 5 inches off of here? No. What's the most I can do?
4.
Right at 4. Like if you do 4, you're right there. So that's so 4. So if you look at this graph, the only piece that is of concern to us is right here. I can't take a negative amount out. Okay. Down here, okay, this is part of that function. It's fine, but this is the only part of the function that relates to the problem. Graphic, see what that maximum value is right there.
What I did. Where are you going? Keep working with that.
I can get to the point when Zoom button.
Okay, yeah, but also.
No, like the yellow chain up on that.
Okay. Think what the dimensions. Yeah, I want you to think what the dimensions would be as well. I know it doesn't say there.
You got your drop in?
Right here.
No. Seems to wide out in my Tim, what are you? Oh. Oh.
Yeah.
It's kind of awkward. That's real awkward.
We have some.
You do. First of all, let's reset that.
I will let you know about that.
Alright.
110,
So you got
100.
you get there.
Spin one more less. So you do second
Figure it out.
bars.
Yeah, let me see what you want to do.
Oh, goodness.
Did you zoom in?
I just
by maximum.
trying to see.
Oh, zoom out. Okay. All right, let's take a look at your graphs. Oh, that's awful. You did zoom fit, didn't you?
Yeah.
I told you it doesn't work. You won't believe me. Why won't you believe me? Like, look, I know a few things in life. Not a lot. I know a few. Zoom fit sucks. Don't use it. Okay? It's not going to help you. Be smarter than the calculator. Okay? But you're going to keep doing it. You're going to keep doing it. It's just how it is. All right, so I'm going to put in this function. So 15 minus 2x, 8 minus 2x, x. All right, I got, I'm just going to start with the standard winner just to see what the heck happens. All right, this is what you get. You got no idea what it looks like. It looks nothing like what we have here. You don't see that maximum. But the main thing is you got to look at your x values. We got to make sure we hit really we only need 0 to 4, but make sure you go 0 to 7.5. So you don't really need to change the x-axis. When you change that, then things get really messed up. So I'm going to see, all right, we talked about this. This is probably what we want. I want to at least figure out what's going on there. So I look at my table, and between 0 and 4, what's the maximum value it's giving me? It says 88. 0 and 4, it says 88. So I at least need to see that. So I'm going to also check in between 4. 7.5 doesn't show up as a whole number, but it goes down to negative 72. So I'm just going to go up to 100 and down to negative 100, just to see if I can see everything. Okay? So y equals, or window, negative 100 to 100. I'm going to make that 10. And we'll hit graph. Now it looks like what we got there. Okay, now you see the shape of it. We're looking for the maximum volume. Okay, volume is length times width times height, determined by how much I'm going to cut out. So I go to second, calculate, maximum. And enter. Enter. All right, 1.67. My y value is 90.74. Okay, so x equals 1.6, or x equals 1.67. Y equals 90 point, was it 74, I believe? Okay. So first let's answer the question. Madison Lloyd, what's the maximum volume? 90.74. Yes. All right. So this answers the question. What dimensions will give me that maximum volume? So now you're the engineer, you got to create the maximum volume, you got to tell the people how much to cut out. All right. What do you do? Carlos, what do we do?
I'm not sure.
You're not sure. Pass it up to the senior engineer, right?
Yeah.
Okay. You're still learning on the job. All right. What do we do? What's going to be the dimensions? Tim, what does this x represent? One. I'm going to make it 1 2/3. What does that represent?
The X.
Yeah. It's the amount we cut out of each side. It's the amount we cut out of each side. The height, what did we say the height was? You guys already told me the height. Height's what? X. So what's going to be the height? 1 2/3. What's the width? The width's 8 minus 2x. And what's the length? 15 minus 2x. Plug in 1 2/3. See what you get. You got to be able to take this last step. Put everything together. Oh, 1 2/3. What is that? That is 5/3. So this is going to be 8 minus 2 times 5/3, which is 10/3. You can keep it in a decimal. I just like this here. 10/3. So 8 would be, so I believe this is 14/3, which is 4 2/3. And then this would be 15 times 3, 45, 35/3, which would be 8 2/3. We have agreement? Anybody? All right, Luke got thumbs up. So now my dimensions are 8 2/3 by 4 2/3 by 1 2/3. Okay, for that one. So that would give that maximum volume, 90.74. All right, start that problem. Do something. Highlight it. Go back and redo it. You need to be able to do it. Okay, you need to be able to take an equation, give me the informal graph, use your calculator, come up with a maximum. Okay, for that. All right, homework-wise. I know we haven't gone over these, but here. 35, 39, and 41, you just had to determine end behavior. 56, make sure there's a negative out in front. Okay, the whole thing is to get the end behavior to be correct, just throw a negative out in front. Okay, so negative x minus 1, x minus 3, x plus 1. 58, put a negative out in front. I guess all these even ones end up being a negative. X minus 2 times x plus 1 squared. 60, negative x minus 2 quantity squared. X plus 2 quantity squared. 62, negative x squared times x plus 3 times x minus 2. Okay, and those are just taking the graphs and coming up with the equation. Okay, does it bounce there? Does it go through? Okay. For 65, And I'm just looking for the general shape. So it hits at -3, goes through, bounces at 1, goes through at 4. That's all I need to see. For 68, go ahead and do this one. It hits at -3. It hits at +2. And it bounces at both of them. 4th degree. It's going to look like that. And then 69, we got a bend, multiplicity of 3 through here. We got a bounce at 1, and we go straight through 3. So it should look like that. Make sure you got a clear bend. Like I said, you kind of come down to the left of the point, then you want to go through the point on the x-axis and then come back down, okay, for that one. All right, questions on any of those? All right, we're moving into section 3.3. I don't have guided notes for this first part of it. We're just going back to old school division. We'll get to the remainder factor theorems tomorrow. Tomorrow, late start. Make sure you put that on your calendar. Late start or early breakfast. I don't know what you guys do on those days. All right, and this just quick question here. You don't need to get this down. Do you remember how to do 28,314 divided by 22? Remember how to do that? Other than without your calculator? No? Oh, we're in trouble. So remember, you take 22 into 28,314, like that. All right. Luke Hirschberg, you remember what to do?
You see if 22 goes into 2 first, and then if it doesn't, you put a 0. Then you get 1.
All right, I'm not going to put the 0. Yeah. So we keep going down the line. Does 22 go into 28? Then you go to see, does 22 go into 28?
Yeah.
Yeah, how many times?
1.
1. So you put a 1 there. Then what do we do with that 1 into 22?
You subtract it from 28.
Well, you got to multiply them first. But I think you know what you're doing. So that, and then you say, all right, then you subtract, and you can get 6. And then what do we do from there? We bring down the 3. And then you say, how many times does 22 go into 63? Well, how many times does it go into it? Those are good questions. Twice. So you put a 2. And then we say 2 times 22 is 44. And then we subtract, right? And what's 63 minus 44? Better be 19. And then we do what? We bring down the 1. How many times does 22 go into 191? That is a great question. Well, I'm going to say 8 or 9. I don't think 9. 9's too many, I think. So you can use your calculator and cheat and see. I think it's 8. What's 8 times 2 is 16. Carry 1. 8 times 2 is 16. So it's 176. Subtract. What's that give me? 15. Bring down a 4. Oh, 154. Ooh, does it work out exactly? Is that 7? 7 times 22, 14. Carry 1. Huh. It's a 0. 0. All right, so it worked out even. What do we do if we get a remainder? You got a remainder of 1. Remember you put it over top of the divisor? All right, so this is what we're going to do, but we're going to throw some polynomials in there. So you kind of got to remember this process. All right, from going back in the Wayback Machine. All right, a polynomial. We talk about things being factors, and it's one of those things you kind of just take for granted. A polynomial d of x is a factor of a polynomial f of x. If there's another polynomial such that f of x equals d of x times q of x. Basically, two things multiply together to get a third thing. Now, you are way more comfortable with constants. So what I'm going to do here, quit doing that. is if you just think of 6 equals 3 times 2. 2 and 3 are both factors of 6. Okay? Because 2 times 3 gives you 6. All right, so that would be the case. So 2 and 3 are factors of 6. If we think about polynomials, x squared plus 6x plus 8 equals x plus 4 times x plus 2. What can you tell me about x plus 4 and x plus 2? They are what? They are factors of the third polynomial. Okay? So this is the case. So x plus 4 and x plus 2 are factors of x squared plus 6x plus 8. Okay. So now we're going to apply this to polynomials. We want to see whether something's a factor. Now, remember, what happens here? What's 6 divided by 3 equal? Go back to just your regular math. 6 divided by 3 equals 2. What's 6 divided by 2 equal? 3. So what's x squared plus 6x plus 8 divided by x plus 4 going to equal? It's got to equal x plus 2 because those two are factors. Okay? So now this is where we're going to use our division properties. All right, we're going to use long division. So we're going to divide 12m squared plus 7m minus 12 by 4m minus 3. And we'll come up with an answer. So when you divide, you find factors. When you do 6 divided by 3 equals 2, then you know 2 times 3 are factors of that original. So this is going to give me 4m minus 3 divided into 12m squared plus 7m minus 12. We're going to do long division like we just did with those constants. Okay? Just this first step is slightly different. Okay? Here's how I'm going to tell you to do this. Just worry about the 4m. And we want to take and see how many times the 4m goes into 12m squared. Just do those two. The other way to think about it is what times 4m gives you 12m squared. Sometimes that's a little bit easier. What times 4m gives you 12m squared? It would be what? 3m. So that's what's going to be our term up here. So that's going to be 3m. So you take that and you multiply it by our divisor out in front. 3m times 4m is 12m squared, but then you got to take 3m times negative 3 is minus 9m. What do we always do after we multiply to get that answer down there? We subtract it, right? You got to subtract that whole thing, which means you got to put it in parentheses. So what do I actually get when I subtract? Now here's the whole point this works. 12m squared minus 12m squared, that should go away, gone. What's 7m minus negative 9m? 16m. Got to make sure you subtract it. So 16m, and then we bring down the next term, which is minus 12. We got to bring that down. So now here's what I wanted to do is say, all right, how many times does 4m go into 16m? Or what times 4m gives me 16m? It's going to be what? 4. Positive or negative? So you got to put a sign in between here. It's got to be a plus or minus, so plus 4. So 4 times 4 is 16m. 4 times negative 3 is minus 12. Subtract. And what does that whole thing give us? Ends up equaling what? 0, which is good. 0. So 12m squared plus 7m minus 12 divided by 4m minus 3 equals 3m plus 4. That also means that that 3m plus 4 is a factor of that because it did not have a remainder. Okay. And it also tells us what does 3m plus 4 times 4m minus 3 give us? It gives us that original. Okay. Not all of them work out to a remainder of 0. All right, let's take a look at this one. 4x cubed minus 4x squared minus 9x plus 5 divided by 2x squared minus x minus 5. So now I'm gonna write it out. 2x squared minus x minus 5 divided by 4x cubed minus 4x squared minus 9x plus 5. All right, what times 2x squared gives me 4x cubed? Just worry about the first two at a time. And that's just going to be a 2x. Now, a lot of times, whatever your degree is, like if this is a 2x, you'll put it over here. I'm not as concerned about that. I mean, a lot of times they'll tell you to do that. It really doesn't matter to me. But 2x times 2x squared gives me 4x cubed. 2x times negative x gives me minus 2x squared, and 2x times negative 5 gives me minus 10x. You're going to subtract that whole thing. Okay, subtract that whole thing. All right, just be careful with your negatives, okay, and positives, and making sure. So think about what we're going to get when we subtract. All right, Colton, what should we get? What do you think?
Would the 4x cubed disappear?
Yep, 4x cubed minus 4x cubed, they're going to be gone, and that's like that's the main reason we picked the 2x. So that's gone. Okay, then what do we have?
Then would it be negative 6x?
No, because you got to do negative 4 minus negative 2. Because you got to treat that as you're subtracting everything. So it's going to go in there, it's going to change all those signs.
Okay.
So then what's that going to make that?
I'm not sure.
So just think about it as negative 4 plus 2, which is minus 2x squared. So that's just going to be minus 2x squared.
Oh, okay.
That's going to become a plus 10x. So you got negative 9x plus 10x, which is plus x. And then we bring down the plus 5. Now you got a negative 2x squared. This is a positive 2x squared. So you want to say, how many times does it go into that? You want it to match up. What times 2x squared gives me negative 2x squared? It's just going to be what? Negative 1. So you got to put the sign with it. Make this a minus 1. So negative 1 times 2x squared is minus 2x squared. Negative 1 times negative x is plus, oh, hold on. Yeah, is plus x. And negative 1 times negative 5 is plus 5. You're going to subtract that whole thing. What happens when we subtract everything? Everything cancels. We're left with what? 0. Okay, good. We're left with 0. So that equals, so the answer is 2x minus 1. All right. At least let's get this next one set up. Now, as you're writing down, pay attention to the top. It's missing a term. What term is it missing? X squared. So we're gonna have to account for that when we write this out. So when we divide, you're gonna make this 2x to the 4th plus 3x cubed plus 0x squared. If you're missing a term, you have to account for that spot. Minus 5x plus 4. Okay, minus 5x plus 4. All right, you finish that on your own. That's the only thing I'm going to give you for homework. I'm not even going to call it homework. Just finish that. We'll continue on this tomorrow. We got late start tomorrow. So we're going to have to hit the ground running, which means I'm going to give you these guided notes now just so that you have them. Okay, we do have to finish a couple things, but I'll hand these out now. You will get a remainder on this one, it will not be zero. If I remember right, and I'll show you what to do with that.
So, then, Commissioner Cabo, Commissioner Cabo. Do that. Why? No, we can do it in free, so we can-